Hello there and welcome to Lower 6th Further Maths A-Level. This is the core part of the sample assessment material. Here we're on a matrices question. So question 5a is to show that matrix M is non-singular. So if it's non-singular, then it means that it does not have a determinant of 0. So to work out the determinant of the matrix, we'll multiply the leading diagonal and subtract the other diagonal multiplied together. So it's going to be 1 take away root 3 times minus root 3 is minus 3. So here we get a 4. So this is obviously non-singular. Singular means that a matrix will have a determinant of 0. If it doesn't have a determinant of 0, it doesn't have an inverse. So hence it is on its own. It's a single matrix. There is no pair or no inverse that is its buddy. Okay, hexagon R is transformed into hexagon S by the transformation represented by matrix M. Given that the area of the hexagon R is 5 units squared, calculate the area of the hexagon S. Well, this is nice and easy. The scale factor of area enlargement is exactly equal to the determinant of the matrix. So it's equal to 4. So if we're going from R to S, and this has an area of 5, then we must times by 4 if we are transforming under this matrix M to get to 20. So the answer here is 20 units squared. Okay, part C then is the matrix is transformed, represents an enlargement at centre 0, 0, and a scale factor of k, followed by a rotation clockwise through theta degrees. Okay, so find the value of k. So if the scale factor, if the area scale factor enlargement equals 4, then the length scale factor enlargement is the square root of 4, which is equal to 2. So the value of k is equal to 2. And that's come straight from a bit of GCSE knowledge that if you have an area and it's been magnified or shrunken down by a scale factor, the lengths have had their scale factor adjusted by the square root of that value. And the same with volumes, it's the cube root. Find the value for theta. Well, okay, once we've done that enlargement, our matrix is going to look something like this. So let's do a check on what sort of transformation that is. If we start with the coordinate A at 1, 0, and with the coordinate B at 0, 1, then our coordinates must end up, well hold on, I've created the identity here, so this is going to be an easy multiplication. It's just the same as what we had here. So my A coordinate is going to end up at this first part here, because if this part was coordinate A, then it ends up here. So that's going to end up at a half root 3 over 2. And for B, the second one here, this is going to end up at the second part of this matrix here. So that's going to be minus root 3 over 2, a half. So that's going to be over here. So from recognizing that this is going to be a 30-degree rotation here, because sine of root 3 over 2, so inverse sine of root 3 over 2 is 60, so that would be a 60 degrees here, and for cos of a half it's going to be 60 as well. The rotation here, if it's rotating anti-clockwise, which it evidently is, the rotation is theta equals 60 degrees round from there. And you can see that B is moved round as well. That's a 60-degree turn and that fits the 30 degree around there. Okay, so that's 7 marks for the whole of that question 5.